the velocity and accelerations and how it can be applied in real-life situations. Hi, don't worry, I will explain to you. Motion is the way we describe how objects move along paths. To describe motions, we focus on two key quantities, which is velocity and accelerations. Velocity tells us how fast a car moves and in which directions, while accelerations tell us how the car velocity changes over time. Understanding these two concepts allow us to analyze and predict the car's movement. In these presentations, we will explain how it can be applied in real life. Stay tuned! So before we move to the problem statements, so this is the formula that we will use in these presentations.
Problem statement. A car A is traveling along a straight highway with an initial velocity of 20 meters per second. The driver accelerates uniformly in order to overtake another car B. At the same instant, car B is 16 meters ahead of car A and is moving at a constant velocity of 28 meters per second. Car A accelerates uniformly until it overtakes car B. After overtaking, car A continues moving with constant velocity equal to its velocity at the overtaking point. From the problem statement, car A starts with an initial velocity of 20 meters per second and accelerates uniformly while car B is 60 meters ahead and moves with a constant velocity of 20 meters per second. The situation analyzed is the moment when car A overtakes car B, which means both cars are at the same position at the same time. This condition allows us to form the first equation by equating the distance traveled by both cars. For car A, the distance traveled is described by S equal to ut plus 1 over 2 at square, which gives 20t plus 1 over 2 at square, while for car B, which has a 16 meter head start and move at constant velocity, the distance traveled is 60 plus 28t. By equating these two expressions, the first equation relating time and acceleration is obtained. The second equation is formed using the velocity condition at the overtaking point. At that instant, the velocity of car A is given as 36 meters per second. Since car A accelerates uniformly, the equation V equal to U plus AT is used, giving 36 equal to 20 plus AT. This equation is then rearranged to express acceleration in terms of time A equal to 16 over t. This expression for acceleration is substituted into the first equation, so that the equation now contains only one unknown time. Solving this equation gives the time taken as t equal to 15 seconds. Once the value of time is known, it is substituted back into A equal to 16 over t to obtain the accelerations of car A, which is A equal to 1.07 meter per s square. Therefore, the time taken for car A to overtake car B is 15 seconds, and then accelerations of car A is 1.07 meter per second square. B. Find the velocity of car A at the instant it overtakes car B. The initial velocity is u equal to 20 meter per second. The acceleration A equal to 1.07 meter per second square, and the time taken is t equal to 15 seconds. Therefore, the formula B equal to u plus AT is used. By substituting all the given value into the formula, the velocity of car A at the instant it overtakes car B is 36.1 meter per second. C. Determine the distance traveled by car A when it overtakes car B. The initial velocity is u equal to 20 meter per second. The acceleration A equal to 1.07 meter per second square, and then the time taken is t equal to 15 seconds. Therefore, the formula S equal to ut plus 1 over AT square is used. By substituting all the given value into the formula, the distance traveled by car A when it overtakes car B is 420.4 meters.
After the overtake,
car A continues at a constant velocity of 36.1 meter per second. To find the distance between the two cars after 10 seconds, we calculate their individual displacement. Car A travels 361 meters, while car B, moving at 28 meters per second, travels 280 meters. Subtracting this will give us a separation distance of 81 meters. Next, we determine the average velocity of car A from the start until the moment it overtakes car B. So we need to use formula average velocity equal to total displacement divided by total time. So by taking the total displacement of 420 and 4.4 meter and dividing it by the total time of 15 seconds, we find the average velocity is 28 meters per second. In question F, we calculate the additional distance car A gained relative to car B during the overtake, while car B traveled 420 meters plus its 60 meters head start for a total of 480 meters. Car A covered 420.4 meters. The additional distance gained relative to car B's position is 59.6 meters. Finally, we need to find how long it takes for the gap to grow to 150 meters after the overtake. We use relative velocity, which is the difference between their speeds, 8.1 meters per second. Dividing the target distance of 150 meters by this relative speed, we find it only takes 18.5 seconds.
Last but not least, in conclusions, velocity and accelerations are important concepts used to describe motions. Velocity tells us how fast a car is moving and in what directions, while accelerations explains how the velocity changes over time. By applying the formula we learned, we are able to analyze the motions of car, whether it's accelerating or decelerating or moving at a constant speed. These concepts are very important in real-life applications such as driving, road safety, and vehicle design.